We're now going to go around the unit circle and label some common ordered pairs. So we're going to view the unit circle in the xy plane and highlight some ordered pairs x, y. And since we're on the unit circle with radius 1, each ordered pair x, y has x and y values related this way. X squared plus y squared has to equal 1 squared, or 1. And this will be an important relation that we will utilize to get some of these common ordered pairs. So we're looking at the unit circle on a grid here. Let's see, maybe I can zoom out just a little bit. Excuse me while I get adjusted. And we might look at the quadrantal angles first and where they intersect the unit circle. And here at the east pole, we would have the ordered pair 1, 0. We can move 1 unit to the right and 0 units upwards, and we're at the terminal side of a 0-degree angle. Now its mirror reflection is over here at -1, 0. 1 unit to the left, we intersect the unit circle, and that would be 180 degrees of rotation to get to that position xy where it intersects. Now if we were to move 1 unit upward, we could highlight the ordered pair 0, 1 and its mirror image 1 unit downward, 0, -1. Okay, so a 0-degree angle, its terminal side intersects the unit circle at 1, 0. A 90-degree angle, its terminal side intersects the unit circle at 0, 1. 180 degrees, its terminal side intersects the unit circle at -1, 0. And then we've got 3/4 of the way around, 270 degrees, its terminal side would intersect the unit circle at 0, -1. Okay. Now let's look half a unit to the right and move straight up until we intersect the unit circle. Since we moved a half unit to the right to 0.5, our x value is going to be 1/2. What will our y value be? So this may be one of the key points of the video that you might want to pause and think about along the way or after we get done here. But since that y value is 1/2, and since we're sitting on the unit circle, I meant the x value. Since we're on the unit circle, the x value squared plus its corresponding y value squared has to equal 1. That means 1/4 plus y squared is 1, or y squared itself has to be 3/4. If we take the square root of both sides, we're going to get 2 roots. We'll get the square root of 3 on top and the square root of 4 on the bottom, which will simplify to plus and minus square root 3/2. Now we were in the first quadrant. We needed to move upwards, so the y value is going to be the positive square root 3/2. All right. Well, we're going to utilize the symmetry of the unit circle. So if instead of moving half a unit to the right, we had been at the origin and moved half a unit to the left, move straight up until we hit the unit circle, we can highlight a reflection of our first ordered pair. Its x value would be -1/2. But with x squared plus y squared needing to be 1, you can go through the calculations again, but you're going to get the same y value as we had before, since they are mirror images about the y-axis. Okay, now remember the signs of the x and y values in each quadrant. Quadrant 1, positive, positive. Quadrant 2, negative, positive. Quadrant 3, negative, negative. And quadrant 4, positive, negative. And that'll just assist us when we do some more reflections. Let's take this ordered pair, reflect it straight across the x-axis until we get its mirror image in the third quadrant. And we'll label that -1/2 negative square root 3/2. And if we took our ordered pair from the first quadrant and reflected it straight across the x-axis, right here, we'll highlight positive 1/2, negative square root 3 of 2. And it turns out we have ordered pairs that correspond to some of our common angles from our previous videos. Let's see if I can. We've got our 60-degree angle. Its terminal side intersects the circle at 1/2 square root 3 over 2. We've got 2 pi over 3, or 120 degrees, terminal side intersecting at negative 1/2 square root 3 over 2. We've got our 180-degree angle. We'll add 60 more degrees to that. And then we'll add 60 more degrees to that. Okay. Now, let's look at the bisector of the quadrant. That bisector lies along the line y equals x. And if we reflect this ordered pair, 1/2 square root 3 over 2, over the line y equals x, we will land right here where the x value is square root 3 over 2 and the y value is 1/2. You can see 0.5 straight across, y value 1/2. And that's the ordered pair that corresponds to a rotation of pi over 6. Okay, so you might want to stop and think about it. Our bisector in red lies along the identity y equals x. And way back when we studied inverses, we learned if we had an ordered pair AB reflected across the identity, it would become BA on the other side. So our 1/2 square root 3 over 2 reflected would be square root 3 over 2 comma 1/2. And now we can find its mirror image in the second quadrant. So I'm going to stay at the height of 0.5. But now I get negative square root 3 over 2, 1/2. I'm going to reflect it down right about here in the negative quadrant. And then I may just want to start over from the positive quadrant, the green, and I'm going to reflect it down here past the x-axis, and I'll get what? Square root 3 over 2, negative 1/2. Okay. So these green ordered pairs, let's make sure I got that right. Did I get that lined up right? Yeah, and that lined up. These green ordered pairs are at the terminal sides of some multiples of pi over 6. So if we drew the radius here, I would have a rotation of 5 pi over 6. And if I drew the radius here, a rotation of 7 pi over 6. And if I drew the radius here, I'd have almost a complete rotation, but I'd have 11 pi over 6. Okay. So we've got several common ordered pairs labeled, and I just want to quickly go back and do the bisectors. And as an exercise, you might want to show that square root 2 over 2 comma square root 2 over 2 does lie on the unit circle. Just show that x squared plus y squared is 1. And then if you will reflect, you will get the terminal sides of some angles whose measure would be a multiple of pi over 4. Okay. So in our next video, we'll start with our unit circle already labeled, and we'll talk about evaluating trig functions for these common angles. Thank you.